In this video, we're going to take a look at hydraulic system components, including reservoirs, filters, and coolers, and why it's important that when we are changing these that we follow the manufacturer's recommendations. So one of the things when we're dealing with the oil is making sure that it's clean. Dirty oil or ingress contamination is one of the biggest problems we have with the hydraulic system. Dirt debris gets in the system, we don't have the right filter, and our components start wearing out prematurely. So when we take a look at, for instance, a spool valve, any moving parts that we have, there's usually a small film of oil that's on these moving parts, and it helps to seal these parts. And if that oil is dirty, it's going to start to wear out these components, and we're going to start to get some slippage or some leakage through these components. When we're taking a look at hydraulic systems and failures, again, it doesn't matter whether it's an engine, transmission, differential, any hydraulic system, the first indication of a failure is heat. As oil is trying to squeeze through a component that is starting to fail, it starts to generate heat, and we'll see that when we start doing some troubleshooting and looking at hydraulic systems. So we really have to make sure that we maintain our oil, filter it properly, have the right micron rating for our filters, and making sure that we service our machines at regular intervals. So taking a look at a hydraulic system, the basic hydraulic system, we have a reservoir. Now, as oil is returning from the system, it has a lot of heat in it. So a couple of things we want to do is the reservoir is going to help dissipate some of that heat to get rid of it, so our oil doesn't thin out too much. The other thing we have in our reservoir is we have baffles in the reservoir, and we also have a screen on the intake side. So we want to be able to allow that oil from when it returns to the tank before it's taken back into the hydraulic pump, have a chance to cool. It also allows a chance for any air that happens to get into the system to vent out, and any debris that's returning to the tank to either be picked up by a filter that's before the tank or settle in the tank. Now when we take a look at grades of oil, and again, as we heat an oil up, it tends to thin out. So for a hydraulic system, we use a winter and a summer grade. So in the winter time, our oil is a little bit thinner so that it will flow easier. Now one of the big problems we have is people that start equipment and they don't give it a chance to warm up properly. And what can happen then is the pump can try and put out more oil than it can take in, and the pump will cavitate, and we'll take a look at what cavitation is and aeration a little later. So we should really go with what the manufacturer recommends for the grade of oil that we're going to be putting into a machine, according to what the temperature outside is, the working temperature. So here we can see what the viscosity changes with temperature. So again, at minus 35, 15W40 barely even flows, but 0W30 does. So again, when we're dealing with hydraulic systems, we have to use the proper oil. And what does oil do for us? Well, oil creates a barrier between two moving components, and it keeps these components from metal to metal contact. And again, it also does a little bit of sealing for us, especially when we're dealing with a hydraulic system. And we're going to take a look later at, again, what happens as a pump starts to wear. So again, the capacity of our reservoir has to be sufficient enough so that it will allow that oil to cool before it gets drawn back into the pump. If it doesn't, it's just going to keep increasing in heat and increasing in heat, and then eventually our oil is going to start to degrade. Once oil gets to a temperature of around 250 degrees and it starts to increase above that, we get what's called oxidation of the oil. And it just basically, it loses its ability to lubricate properly, and it starts to pick up oxygen. So taking a look again at the reservoir, again, as that hot oil is returning, we want to be able to dissipate that heat out. Now, a lot of our systems now on the return side will have a hydraulic oil cooler, which again will help to cool that oil before it gets back to the tank. Some of our reservoirs are in places where they don't have a lot of airflow, so we can't cool them properly. So again, having a cooler before the reservoir is going to help. And again, we get to remove the air and the solid contaminants before they go back into the inlet of the pump. Now, the inlet of the pump will always have some type of a strainer on it. We talked about this in one of the last videos. And again, these strainers are made of stainless steel or brass, and the simple reason is we don't want anything magnetic so that magnetic particles can attach to it. So we'll put magnets in the bottom of the reservoir, and that will trap any of the metal particles coming back through the system. Now, on the suction side, they have a screen, and again, the screen is rated as what's called a sieve rating, and a sieve rating is how many holes per linear inch. And again, it will depend on what type of oil we're using, because if we don't have sufficient flow into the pump, we're going to get what's called cavitation, or we could even get aeration in the pump. Now, vented reservoirs, we talked about this when we were in one of the previous videos. We have either a vented reservoir or a sealed reservoir. So in a vented reservoir, there's two different kinds of vented reservoirs that we might see. Now, some very simple ones is we have a filter on the intake side of for the breather, and it allows fresh air to come in. As temperature starts to increase, the oil is going to expand. Well, that oil that's expanding is going to displace air, and that air has to go somewhere. So it gets pushed out through the breather and the filter. And then when the engine's shut down and the hydraulic system isn't working anymore, that starts to cool, and as it starts to cool, it wants to contract. And when it does that, the vented reservoir, the breather, allows air to come back in to replace that volume that's being displaced as it starts to shrink. The other type is a closed reservoir. Now, we talked earlier also about what's the best one to have. Well, what we want is we want a reservoir that can be pressurized, and the reason for that is we don't want the pump to cavitate. So if we can pressurize the system, we can force that oil into the pump. Otherwise, it's just atmospheric air pressure that's pushing it in there, and it may not be enough pressure to keep that pump totally full. So if we take a look at a hydraulic reservoir cap, it's very much like a rad cap. So we have two valves in here. We have a pressure valve and we have an atmospheric valve. So the pressure valve is set up to only allow, let's just say, 12 psi of pressure. Anything over that gets vented out to atmosphere. The atmospheric valve is set up so that when the oil cools, atmospheric pressure can force this atmospheric valve open, and it will allow atmospheric pressure back into the tank. There are some instances where we are going to use air pressure to pressurize the tank. Now, this isn't 150 psi of pressure that we're using. Again, you'll have to check with the manufacturer of what they want. Thing to note is anytime that we're working on a tank, make sure that we turn off the pressure and vent the tank before removing any filters, otherwise we're going to get covered with oil. So on this one here, there's a shut-off valve, so you can just shut it off, and then there should be a place to vent the tank. In some of the reservoirs, the screw cap, as you start to remove it, it opens up a vent on the cap itself and will allow that tank to vent. Now, if we're taking a look at two common types of level indicators, so if we have a dipstick, the tank is not pressurized, otherwise we'd just blow the dipstick out. If we have a sight glass, chances are that that tank is pressurized. Now, keeping the oil level at the proper level when we're working it is really important. Again, not only we want to be able to cool that oil, and if the oil level's too hot or too low, it's not going to have a chance to cool and we're going to overheat our oil. The other thing we see on a lot of equipment is on the inlet where we fill our filler cap with hydraulic oil, we're going to have a strainer, and this is so when we're adding oil to our hydraulic reservoir that we don't get any contaminants in. Again, ingress contamination. We're going to take a look at filters later, but this is the first line of defense. So what I'd seen before is someone has taken screwdrivers and they punched a bunch of holes in there because they didn't want to wait for the oil to drain through the strainer. Well, now you just defeated the purpose of having a strainer in there. It doesn't do any good. You'll also see this type of strainer in a fuel system on a fuel tank. And again, they're there for a reason, so make sure that they're not damaged. The other thing we take a look at on the line location on the return line is the inlet line. If it doesn't have a filter on the end, it's cut at a 45 degree, and that's to force the oil away from the inlet pipe. Now we also have baffles in there, and the baffles inside a tank are there to help separate the two sides so that it gives the oil a chance to do its thing again, whether it's get rid of air, let particles settle out, so that when the oil gets back to the inlet side, it's cooler. Now, depending on the tank, there's usually always a place to clean out the tank. So you'll have again, first thing you want to do is drain all the hydraulic oil out. Then you want to remove the cap. Now, in some cases, these will also be a filter. But you also want to get inside and look at any of the magnets and clean out the bottom. So let's just say once every year you're going to do a service on this where you're going to drain the oil out, you're going to clean out the reservoir, wipe it all out, see what's in there, and you'll be surprised at what you'll see. You'll see pieces of packing, pieces of brass. And again, if we start getting too much stuff in there, we got to figure out where this is coming from so that we don't have a failure down the line that's going to put the machine down. So avoiding any turbulence inside there that can aerate the oil, and again, making sure that the baffles are in there, and every tank is built differently with different amounts of baffles and how they're set up, just so that we prevent the turbulence inside the reservoir. When we take a look at filters, again, particle size is a big thing. So what we want to do is we want to know what ratings are. So I talked about a sieve rating. So sieve rating is on the pump side, and it'll be how many holes per linear inch. So sieve rating of 50 is around 52 holes per linear inch. Now the micron rating, if we take a look at it, is quite large because the oil coming back in should be pre-filled or pre-filtered. But this is where ingress contamination is going to cause us a lot of problems, where if we allow dirty oil to get in, it can get through this sieve rating or the micron rating and get through our pump, and it's going to slowly destroy our pump. So for us, when we take a look at what the manufacturer recommends for a micron rating, so how a filter works is if we have a micron rating of 8 microns, that filter is going to catch anything that's 8 microns or larger, but anything that's smaller than that will allow it to go through the system. Now we don't want to just take, and if we're supposed to have an 8 micron filter, put a 2 micron filter on there. because it's going to create back pressure in the system, and we don't want back pressure in the system. So bottom line is, what does the manufacturer recommend? And buying cheap filters. Cheap filters are cheap for a reason. So when we take a look at a basic filter, so what we have is a pleated medium, and this is what traps our particles as they're coming back in. So oil is going to enter, go around through the pleats, through the center, and back up and out. Now, the more pleats we have, the more surface area we have to trap particles, and the longer the filter is going to last. Again, buying a cheap filter, you may have to replace it more often because it's going to get plugged too often. So always, again, whatever the manufacturer recommends for a filter. So there's so many different types of filters out there. We're not going to go into each and every type. There was one type of engine oil filter that they used a roll of toilet paper in. So again, we want to be able to capture these particles before they can get through the system. There's also another rating for filters. It's called the beta rating. So if we have a beta ratio of 1, our filter is 0% efficient. So in other words, it's not doing anything for us. But when we get up to, say, 1000 beta ratio, we're 99.9% efficient, and when we get up to 5000, I've never seen this as for rating filters. I've always seen the micron rating. So again, strainer locations. So as we're pouring oil into our reservoir, we have a strainer, and we also have an inlet strainer, and this inlet strainer is to protect the pump. If we take this off, all it takes is one piece to go through that pump, and it can destroy the pump. The other thing you might see on some systems is a high pressure filter, and it's on the outlet side of the pump, and it's there to protect everything downstream. So if I have a pump failure, that pump, all the pieces from that pump, when it fails, are going to go into the high pressure filter, and we don't have to disassemble the whole system to clean it out. So taking a look at a schematic, and that's what we looked at last time. So we have our inlet screen that goes into our pump. We have a relief valve. We have a high pressure filter, and it goes out to the system. Return line filters, again, some have it, some don't. So return line filters can be placed anywhere. They can be in the tanks. So to service them, you have to remove the inlet, and it's sitting in the bottom there. So again, it all depends on what type of system we have. If you're not sure, look in the service manual. It'll tell you where that is located. The other thing we want to take a look at is a bypass filter operation. And this is one of the reasons why we want to make sure that we warm our oil up properly before we start running the machine, because if the oil is too thick and it can't get through our filter, what's going to happen is it's going to open up the bypass. Now we're just dumping any dirty oil back into our system and not allowing it to filter it. So we want to ensure that we let it warm up enough properly before we run it. The other thing we might see is we might see a switch on here. So if the bypass does open, it'll trigger a light inside the cab to let you know that the filter is bypassing. Again, a restriction indicator. Very simple. We're going to get into electrical next, but it's a normally open switch. If the pressure gets too high on the return side, it's going to close the contact and trigger a warning light. Now, what about pipe sizes? So we take a look at pipe and tubing. Pipe is measured in the ID, tubing is measured in OD. We're going to take a look at different types of piping and different types of fittings that we might see in a hydraulic system. Pipe thread. So there's two different pipe threads that we're going to see. National pipe thread, which again, when you take a look at National Pipe Thread compared to National Pipe Thread fuel, the one with the fuel seals properly at the bottom of the root of each of our threads, and that way we don't need to put Teflon tape on these ones, where when we're dealing with this one we have to, because the oil will go all the way around and leak out the end if we don't put pipe sealing compound on it. Now, one of the other things that we have to take a look at is the type of restrictions that we're going to have in a system. For instance, if we have a 90-degree elbow, as that oil is being pushed around 90 degrees, it will create a restriction to flow. So what might be better is to put 245s in there. Now, anytime we're dealing with hydraulic systems, we cannot use cast fittings, cast iron. It can't handle some of the pressure. So on the return side it's fine because we don't have any pressure on the return side, but on the pressure side we do not want to use any cast iron fittings. So when we're taking a look at steel tubing, again, steel tubing is measured outside diameter, and how do we measure it? Well, it would be a dash number, like dash 4 would be 1/4 inch, so it's on a 1/16 of an inch scale. So dash 16 would be 1 inch, dash 8 would be 1/2 inch, dash 10 would be 5/8, and so on. So different types of flare fittings that we're going to see, and again, one of the things when we're dealing with steel fittings, there's a thing called work hardening, and it happens more with copper than steel, but it can still happen with steel. So what they do is they'll put a sleeve on the fitting before they put the flare in, and that'll help support it, because usually this is where it cracks, right in this area here. So by having that sleeve on there, it helps support the flare and helps prevent the bending. Other types that we might see, again, National Pipe Thread, or we might see ORB. So that's an O-ring boss or O-ring base. And again, anytime we're pulling these apart, we should be checking and replacing these O-rings. Over a period of time with heat, they get brittle and they don't bounce back. So if you take your thumbnail and push on it and it doesn't bounce back, it's time to replace it. The other type you're going to see is a split flange connector, where we have 4 bolts. So we can loosen off all 4, take off 2, and we can slide this out, and it has a flat-faced O-ring base. And again, same thing is when we're looking at these, make sure that O-ring's in good shape, otherwise it's going to leak. Some ferrule type connectors, so these are crimped on, so as we tighten up the nut, this ferrule is going to embed itself into the tube, and that's going to create the seal there and down in here so it can't leak. There's a bunch of different styles, again, how they're set up. Most of these, once they've been crimped once, you can't take the ferrule or the sleeve off. You either have to change the pipe. Not that you can't just take it off and put it back on again, but if you're changing fittings or whatever, you may have to replace the tube. We talked about hydraulic hoses earlier too, again, flexible hoses. And again, when we're taking a look at hoses, making sure, number one, is the pressure rating of the hose matches what the pressure rating of the equipment is. If we're running, let's just say 5,000 psi hydraulic pressure in our system, we want to make sure that that hose is capable of handling what the manufacturer recommends. And again, we don't usually make up hoses. Usually we get a hydraulic shop to do that for us. So they'll need to know what the working pressure of the equipment is when we're ordering the hose so that they can get it properly rated. So hydraulic hose construction, again, number one is, what are we running? If we're running hydraulic oil, we have to make sure that the very inner core is compatible with the oil that we're running. Now, how many wire braids we have depends on the pressure rating of our equipment. Now, spiral wire braid is probably the toughest, but again, we usually let the hydraulic shop figure out what hose we need. As for fittings, you're usually going to take the old hose in there. Now, something, again, I don't want you memorizing any of this. This is just guides for hydraulic hoses. And again, we don't usually make them up. Now, different types of connectors that we're going to see. Making sure that we match up the right fittings with the connectors so that we don't get any leaks. We should never be putting Teflon tape on any of these connectors to prevent a leak. If we're putting Teflon tape on it, there's an issue. We have a leak and something should be replaced. Another thing we see in the bush is reusable fittings. Now, a couple different types that we're going to see. There's ones that are called skived fittings and ones that aren't. Skived fittings, what we have is we have a cutter and we take the outer layer of rubber off so that when we put the socket on, it grabs onto the steel wire braid. It helps prevent it from coming off. If we don't skive it, chances are we probably won't get the socket on properly. The other thing, as we're working on hoses and making up hoses, the smaller the hose, we're going to have to usually take a utility knife and cut a 45-degree angle in the top of the inner core of the hose, and this will help when we put the nipple in to make sure that it doesn't catch a piece of rubber and fold over. The other thing that once we make a hose up is we should be taking air and blowing it through the hose in both directions to make sure that we don't have a flap, and that'll prevent oil flow. And it also helps clean out any debris that was in the hose from when we were making it up. And then once that's done, we should be capping both ends and then taking it to the job site. If we're making it on the job site, we can blow it out with air and then install it on the machine. Another type of reusable fitting, and you need a special machine for this, is this hose is skived, so the outer layer is taken off. And what we do is this nipple is put onto the hose, and then we take a rubber mallet and tap down all the little fingers to make sure it grabs onto the steel wire braid. And then we're going to press the sleeve over top, and that helps keep everything nice and tight onto the hose so it doesn't come apart. So you need a hose machine to be doing this. Not that you can't do it in a pinch without one, but it's much easier to do it with one. The other thing we might have in a hydraulic tank is a heater. Now, in a case like this, we need to have a power source to heat this up. And again, especially when it's extremely cold out, we want to make sure that we're not starting the machine with cold oil, because again, all these components are going to starve for oil as it starts to warm up. Now, what's the fastest way to warm up oil? Well, very gently keep the RPM low until the engine gets a chance to warm up, and then start cycling the hydraulic system very slowly to allow the oil to start to move through the machine, and cycle all of the controls for their complete stroke so that we get rid of all the cold oil and replace it with the warm oil. On the return side, again, we are going to have a cooler, and with the engine running, air is drawn through this cooler to help keep any oil that's returning to the reservoir cool. There should be very little pressure in the return side, and we're going to go through on how to test hydraulic systems later on. So again, looking at a schematic of how a cooler is set up, again, we have a bypass. Now, the bypass, again, if this filter is getting plugged, or the cooler is plugged, the bypass pressure builds up on this side and will open and allow oil to go through to the tank. And again, it may have a sensor on it to tell you that your oil cooler is plugged.